Hello, my name is Hартмут Ханген, and I am responsible for technical training at HUESKER Synthetic. In the following, I'd like to provide you with some information about the topic of sinkhole bridging using geosynthetic reinforcements. The existence of sinkholes and their importance in infrastructure engineering are matters that generally receive little public attention. This situation reverses, however, if traffic routes are affected, compromising public safety and impairing traffic, if not stopping it altogether. There are various causes for the appearance of underground cavities. On the one hand, they can be caused by human activities, such as mining, gas and oil extraction, or groundwater extraction and recirculation. On the other hand, natural erosion processes through water-soluble rock containing chalk, gypsum or salt can also be responsible. Depressions or sinkholes on the surface then appear when, for example, the support systems of abandoned reeve shafts fail due to old age, or eroded natural cavities reach a critical size and the overlying layers of soil are not thick enough or strong enough to bridge them. The appearance of sinkholes is often associated with a change in the groundwater and surface water balance. There are many possible approaches to stabilizing and bridging sinkholes, ranging from safely isolating sinkholes by injecting them with various fillers or erecting extensive reinforced concrete structures. In addition, safeguards can be installed to secure regular traffic permanently, such that no deformations are allowed on the surface during the entire period of use, or alternatively, only for a short length of time, long enough to interrupt traffic in an orderly way so that repair measures can be introduced. The method of reducing the impact of sinkholes using geosynthetic reinforcement is quite simple to explain by an analogy with a clothesline. After excavating a 2 to 2.5 meter thick soil layer, the reinforcement is laid in 1 or 2 perpendicularly arranged positions over the hazard area and anchored outside this area. In the clothesline example, there are the hooks in the wall. Should the cavities be located close to the terrain surface and neighbouring building permit it, it is sensible to perform a deep compaction before placing the reinforcement. The latter process is referred to as dynamic compaction. If a new embankment is to be constructed, soil evacuation is of course unnecessary. If a sinkhole event occurs, the soil loads transfer to the reinforcement, which sags as a result, preventing the soil from completely collapsing. Only with small sinkholes and relatively large covering depths can a supporting arch form in the soil above the reinforcement, but as a rule, the soil hangs completely on the reinforcement. The higher the axial rigidity of the reinforcement, or of the clothesline, the less it sags. As an extreme example, imagine that your clothesline were a steel cable and your neighbour's a rubber band. In addition to strength properties, the creep characteristics of the clothesline reinforcement is very important. If a reinforcement tends to creep, its sag would increase under a load. For this reason, only geosynthetics manufactured from high-quality raw materials with high tensile stiffness and low creep qualities can be used to bridge sinkholes. Aramid and polyvinyl alcohol are the standard materials for this application. Polyester reinforcements are suitable for bridging cavities in small diameters. The required short-term strength of the materials can often be well in excess of 1,000 kilonewton per metre. That makes 100 tonnes on a 1 metre strip. Geosynthetics are ductile building materials. especially in exceptional calculation situations, for example when the calculated diameter of a sinkhole is exceeded, a value which is itself difficult to predict. Securing methods using geosynthetic reinforcements provide a high level of safety. In comparison to steel or reinforced concrete, which are more brittle materials, geosynthetic reinforcements have considerable load capacity despite increasing deformation. In such extreme cases, a design's fitness for use can of course no longer be guaranteed. However, a catastrophic collapse can be prevented under certain circumstances. In contrast, steel or reinforced concrete structures would fail very suddenly without any recognizable advance notice if the load capacity is exceeded. In order that the sinkhole securing system with geosynthetic reinforcement is activated immediately after the sinkhole collapse occurs, high-quality construction and competent construction supervision are indispensable. This is the only way to ensure that the reinforcement is laid without folds and is anchored properly. Damage to traffic routes caused by sinkholes can result in huge impediments in private and public places and traffic, restrictions for extended periods of time. Project experience made over the last 20 years has shown that bridging cavities with the help of geosynthetic reinforcement is not only technically feasible, but also economically advantageous when compared with alternatives, even for railway tracks. I hope that you found this presentation interesting. Should you be interested in further technical details of this specific HUESKER solution, please visit us at our website.